welcome to Retech, and today we're going to cover a comment that was left on a previous video, and it was very good. It was a comment that I had to do something about. I did reply to it, but I thought I'd probably give it a little bit more detail, and it was by Thomas, and he basically asked after the eMac episode about the open and closed architecture of the Macs, because there's a lot of confusion out there about how Apple systems work and why they're closed, can you download software to them, and so on. And I kind of think that it needs clearing up a little bit, so we're going to do that today, and also look at another iMac running again music software, but we'll cover that in a little bit, because first I want to cover his point. Okay, so his point was basically that Macs closed. They're closed architecture, and you can't do much with them, and it's hard to install software, and so on and so on and so on. It's kind of the usual rhetoric you hear, and you also hear it more about the older Macs, iMacs, etc., than you do the more modern stuff, because we're starting to get used to closed architecture. It's not something that's unusual now. It's not something that's out of the ordinary. But if we turn kind of the Wayback Machine way back, everything was closed architecture, really. You've got the Manchester Baby, closed architecture. The ENIAC, closed architecture. The Lions machine, closed architecture. Then you move it up to the slightly more modern, the micros. Okay, most micros were closed architecture. They were designed around a certain value. They were designed around a certain want or need, and that was it. And it wasn't really until Apple started producing micros with open architecture. We're not talking about minis and so on, we're talking about micros. Okay, that was the biggest hitter as far as open architecture is concerned at the time. But we've kind of got more generally used to PCs being open architecture. Now, if you've ever watched any of the Apple documentaries, or the Steve Jobs documentaries and so on, and the movie that came out, you will see was banging on and on and on about the slots in the machine, and that's very similar to the slots in a modern PC. Okay, so you can add in extra cards, configure the machine the way you wanted it, and so on. And that was brilliant. It's great for hobbyists. It's great for being able to expand your machine to do what you would want it to do. But it also inherits problems. It inherits instability. It can inherit issues from overheating, from core processor issues, to memory conflicts, to DMAs, to IRQs. And it's something that, anyone who's brought up around the PC era knows far too much about it, because it was a common thing to try and get these cards and accessories working. Now, as I just said, we are more used to closed architecture now, and it's probably passed you by, and you're probably thinking, no, everything's open, everything's, I'll have a PC, I can do what I want with it. Well, I have a PC, it's a laptop. I've also got desktop PCs. I've also got other machines, such as tablets and mobile phones, and each of these are closed architecture. So if you look at a laptop, there's not really a lot you can do with it. You take it out of the box, it doesn't matter if it's Windows, Linux or Apple, and you get what you have with it. So you run whatever's on it with Windows. You can install customized software and so on, but you can't do much else with it. You can't really add to the sound card, you can't really change the graphics processor on board, you can't do any of that, because this is it. This is the way it came out of the box, and that's how you're using it. And laptops have been predominantly closed architecture from almost day one. You can't have open architecture and portability. You can't have scalability and portability. That's kind of things that really don't mix. So, closed architecture, been around 30 years or more. Then you have tablets, closed architecture. Doesn't matter if it's a Windows tablet or a Linux tablet or an Apple tablet or an Android tablet. Closed architecture. Can't do much with them. You can still install software, which is one of Thomas's questions. You can still download it. You can still put it on CD if you've got a CD drive attached to it and so on, and it would run and install fine, and you would be able to use whatever you wanted to use on it software wise. So they are customizable within kind of that realm. So closed, you know, work brilliantly. In fact, laptops are less prone to crashing than desktop PCs because they are out of the box configured to work that way. And there's the biggest crux of the matter. Open architecture systems involve a lot of issues. It has got much better since Andrew Herbert, OBE, and his team worked on a different driver installation set rather than the previous one that Microsoft used, and his verification of drivers, etc. And we don't see the blue screening that we used to see every 5 or 10 minutes on a Windows machine, and now it's virtually gone. And that's because of better programming, better ideas, better implementation, but you still get pieces of hardware that don't work properly, especially in a Windows environment. So we are predominantly running on closed architecture. Most of the micro PCs that you see out there, the small form factor PCs, are closed architecture. They're almost the size of a Mac Mini, and they do roughly the same thing. You just put it on your desk, plug it in, use a HDMI cable to a monitor or display, plug in a keyboard, and you're done. And that's it. And again, they're pretty much closed. There's not much you can do with them to add in extra cards and so on, and if you do need to do certain things, you can run stuff through USB, and that's the same on Apple devices, and the same on Android devices, and the same on just about every other device that's on the market. Now, the advantages of closed architecture are stability. So stability is a major advantage. And that's one of the reasons why Apple kind of gained its foothold, because they were known as very stable. They have what they have, they run what's installed, and they run out of the box. There's no installing operating systems on board, there's no configuring it, it's just ready to go. And that's quite a good platform to be with, especially if you just want something to work. You want something to check your emails, do your word processing and so on, well, they'll run out of the box. The other advantage of closed architecture is that if you have an iMac or an eMac or any Apple product of the last maybe 20 years, you can switch that on. It will work, it will run, it will still allow you to type your documents up, view your photographs, watch your videos and so on, and it will work correctly. It will work the way it was intended. So if you're plugging in cameras such as a Sony HVR professional DV camera, which is still used throughout the professional industry, and you plug it in via FireWire, which was developed in conjunction with Sony, it will work. It will work out of the box first time. If you decide to plug in USB Midi style keyboards, such as the Korg here, which I did mention in my post, it will work. It will connect, it will see it, it will work. I mean, this Korg actually runs on old school Midi as well as USB, and it's kind of a very practical and a very good instrument. But on Windows, unless you're running a very old version of Windows, it doesn't work, or it doesn't work correctly, or the OS doesn't see it, or the DAW you're using doesn't recognize it, and so on. And that's the problem. So you'd have to go out and junk really what is a good practical working device in favor of a brand new one, just because of the OS has been upgraded and the hardware has been upgraded and legacy devices are no longer supported and so on. So we have issues with moving forward but backwards compatibility, which is, when you think about it, is where the original PC scored highly because it was always meant to be backwards compatible. Now, this is turning into a little bit of a lecture about, you know, closed and open hardware. There's a lot of other benefits of an open platform. They are cheaper, they are easy to manufacture, they use off-the-shelf parts. Very little was proprietary, very little was developed specifically for that machine, apart from maybe the BIOS. And it makes it more accessible to most people in terms of cost. Closed hardware was very different. It was more expensive, it cost a lot more to produce, it was mainly proprietary, and it also entailed a cost that may be speed or adaptability and so on. But again, it was a trade-off. But now we're used to it. We're used to Android, we're used to tablets, we're used to, even Linux has got a massive foothold in the computing world. So it's not so much an issue, open or closed technology. It really, for most people, doesn't matter anymore. But as far as a classic or a vintage standpoint, the closed hardware, the closed systems make more sense if you want to keep them running, and if you want to preserve them, and if you want to still use them. And you know, a lot of the stuff is still more than usable in the last 20 years, and we kind of bypass that and chuck it away, or put it in a cupboard, or forget about it, or give it away, or scrap it. And there's no need for that, when if you can use it for something else, then you should be using it for something else. Now we have a board. It's a Mac Classic system board. It's proprietary. It's really closed. You can't do much with it. You can probably plug in an extra hard drive via its expansion. You can put in a little bit of extra memory, but that is roughly about it. But then from the same era we have a board out of a BBC computer. It was mainly off-the-shelf parts. It did have a ULA, but predominantly it was off-the-shelf parts. But look at the amount of expansion options you have on this machine. Now, this isn't adding in cards and daughter boards and so on. This is literally plugging in stuff to the machine, from disk drives to printers to second processors and so on. And although it's not massively open architecture, it is a lot more expandable than the original Mac was, and this makes it a more useful machine. But nowadays all of these ports are gone and they're replaced by a single USB port. That's it. All of this technology and all of this structure and infrastructure to make each individual port work has now gone by the by, and it's USB, which is the way that Apple was trying to go with its Firewire implementation, and then it eventually went over to USB. So USB took away the need for an open system in a lot of cases, and we're more than happy with that today. So let's take a very brief look at a old iMac, an LCD flat screen one, which still looks very modern, and let's take a look at that running some music. Okay, so thanks for watching, and I hope this has kind of expanded a little bit on open and closed architecture, and I hope that this very kind of brief summary gives you a bit more of an idea of not to be afraid of closed architecture, because you're probably using it now in your phone, on your tablets, in your laptops. Okay, so this old computer open and closed architecture sort of battle really doesn't need to exist anymore. But if you do have a vintage or a classic machine which is closed, you will be more than better placed for preserving it and using it and having fun with it than you would with a very early PC. So thanks for watching, thanks for listening, and I hope to see you soon. Thanks a lot. Bye bye. Mm-hmm.